So this is the third video in hydrocarbons. Last video we discussed the nomenclature and isomerism in alkanes. In this video we will do the preparation of alkanes. Crude oil and natural gas are the rich sources of alkanes. They are the naturally occurring sources. But alkanes can also be prepared by following methods. That is from unsaturated hydrocarbon, carboxylic acid, and from alkyl halide. From unsaturated hydrocarbon, you can use reduction of alkene and reduction of alkyne. From carboxylic acid, you can do decarboxylation, Gibbs electrolytic method, reduction of carboxylic acid. And from alkyl halide, you can do these four methods. By reduction of alkyl halide, Woods reaction, Corey-House mechanism, and by use of Grignard reagent. So these are the methods by which you can prepare alkanes. We will discuss one by one. First, we will take the preparation of alkanes from unsaturated hydrocarbons. Unsaturated hydrocarbon. Unsaturation means either the compound will have a double bond or triple bond. Here you take CH2 double bond CH2. This is the first member in alkene series. We call it as ethene. When it is treated with hydrogen in the presence of nickel at 298 Kelvin, this hydrogen gets added to this carbon. So this CH2 will become CH3. Now this double bond will become single bond, and then this hydrogen gets added to this CH2, so you are getting CH3. So what you are doing is you are adding hydrogen to this double bond, so the double bond will become single bond and you are getting an alkane. So here we have two carbon atoms, all are this one is a saturated compound, so it is called as ethane. ANE you have to add as a suffix to this root word eth. So you are getting ethane, and here since you are adding hydrogen to this alkane, we call this reaction as hydrogenation reaction. Next you take the next member CH3 CH double bond CH2. We have 3 carbon with double bond, so it is propene. On treatment with hydrogen either in the presence of nickel or platinum, this hydrogen gets added to this carbon. So only at the double bond you have to add. So this hydrogen gets added to this carbon. So you are getting CH3. This CH will become CH2. Now this double bond will become single bond, and then this hydrogen gets added to this carbon. So you are getting CH3. So this compound we call it as propane, a saturated alkane you are getting. So this is propane. Now you take another, these are the from alkene series. Now you take an example from alkyne, a triple bond. So this is called as propyne. On treatment with hydrogen in the presence of nickel or platinum as a catalyst. So here this hydrogen gets added at the triple bond. So here this hydrogen added here to C to form CH, and this triple bond will become double bond, and then this hydrogen gets added to this carbon, so you are getting CH2. So what you are getting here in the first step is propene. Next you add one more hydrogen to this one, so you will be getting this hydrogen gets added at this carbon, because this carbon is attached to a double bond, so it is added to this carbon, so you are getting CH3 CH2. Now this double bond will become single bond, and this hydrogen gets added to this carbon, so you are getting CH3. So we are getting a propane. So or you can do in one step by adding 2 hydrogen to this propyne, so that you will be getting propane. So either you can show in this way in 2 steps, or in one step by adding with 2 hydrogen you can show. So these are the methods by which you can prepare alkane from unsaturated hydrocarbon. Unsaturated hydrocarbon means either a double bond or triple bond. From carboxylic acid you can use decarboxylation, Gibbs electrolytic method, reduction of carboxylic acid. So in case of decarboxylation, you have to use the salt of the carboxylic acid. And here in Gibbs electrolytic method also you have to use salt. Salt means you have to take RCOO and then Na. If it is H, then it means acid. So the H is removed and substitute with Na. That is what we call it as salt. Here also you have to use RCOO, Na, the salt of the carboxylic acid. But the reduction of carboxylic acid, where you have to use acid itself. Acid RCOOH, you will have H. So in the case of salt, you will have Na. Acid, you have H. So H is replaced and substitute with Na to get a salt. So these are the methods by which you can prepare carboxylation alkanes from carboxylic acid. So first we will see the decarboxylation. So decarboxylation means D means removal, carboxylation means carbon dioxide. So from this we can understand that there is a removal of carbon dioxide from the salt of the carboxylic acid. So you take RCOO Na. So here the O is minus, Na is the plus. This is the salt of the carboxylic acid, and this can be obtained from the acid, that is RCOOH, carboxylic acid, on treatment with sodium hydroxide. So this is an acid and this is a base. So there is a removal of water. H and OH, they will combine to form water, and the remaining what you are getting is RCOO and then Na. So you are getting RCOO, Na and water. So this hydrogen and this OH, they will combine to form water. The remaining what you are getting is the salt RCOO, Na. So this is the sodium salt of the carboxylic acid. This salt you have to take on treatment with sodium hydroxide, that is you are doing in the presence of calcium oxide. So this is what we call it as, this mixture we call it as soda lime. Soda is NaOH, lime is NCaO. So this mixture you have to use for decarboxylation. Only this mixture we will use. So when you do this one, there is a removal of sodium carbonate, that is from here and from here. So this Na2CO3 is removed, sodium carbonate is removed. The remaining what you are getting is RH, you are getting here. So this is what we call it as alkane. So alkane you are getting on decarboxylation of the sodium salt of the acid with soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. When you do, there is a removal of Na2CO3. The remaining you have to write. For example, you take this CH3COO Na. So this is sodium acetate on treatment with soda lime, that is soda NaOH and lime calcium oxide. So when you treat it with this mixture, there is a removal of sodium carbonate, that is Na2. So this one and then this. So there is a removal of Na2CO3. The remaining CH3 and H is there. So that you will be getting a CH4. So you are getting methane. So this is how you have to prepare. If you want to prepare ethane, you have to take the next member CH3, CH2, COONA on treatment with soda lime. Remove Na2CO3, remaining you join and write. You will be getting ethane. So this is how you have to prepare alkane from carboxylic acid by using decarboxylation method. For decarboxylation, you have to use the mixture soda lime. Soda lime is nothing but sodium hydroxide and calcium oxide. Here in this case, you are getting an alkane with 1 carbon less. Here see CH4 with 1 carbon, but you are taking here 2 carbon acid you are taking. So you are getting an alkane which has 1 carbon less than the carboxylic acid. In all the cases, if you want to prepare ethane, you have to take CH3, CH2, COONA. So here like this, CH3, CH2, COONA on treatment with soda lime. Here you have 3 carbon atoms. There is a removal of sodium carbonate and you are getting CH2, CH3, ethane you are getting. Here you have only 2 carbon, but here in carboxylic acid you are having 3 carbon. So you are getting an alkane with 1 carbon less than the carboxylic acid. This you have to make a note. We have Gold's electrolytic method. Here also we have to use salt. That is RCOONA, O gets a negative charge, Na gets the positive charge. So it is the salt of the carboxylic acid, sodium salt of the carboxylic acid. With aqueous solution, you have to take undoing electrolysis. So electrolysis means you have to take a beaker containing 2 electrodes, and these 2 rods, they are connected to the positive and negative terminal of the battery, and you have to use a solution. That here the solution is RCOONA aqueous, that is aqueous solution of the sodium salt of the acid you have to use, and this acts as an electrolyte, and these rods are electrodes, and when it is connected to a battery, the current will pass through the solution and the following reaction will take place. I will tell the products and then I will explain the mechanism. Now you see the products. Here you have to take 2 molecules of the salt of the acid you have to take. And here in these 2 molecules, these 2 they will combine to form RR, and it is called as alkane. Now here this COO, they will combine to form carbon dioxide, 2 molecules of the carbon dioxide, because we are using 2 molecules of the salt. So we are getting 2 molecules of the carbon dioxide. Now we have sodium and HOH, and here this HOH we have to take 2 molecules we have to take. So this sodium and this OH, they will combine to form sodium hydroxide, 2 molecules of sodium hydroxide. The remaining what you have is hydrogen, 2H plus, they will combine to form hydrogen gas, and this hydrogen is removed as a gas. So these are the products we are getting by this method. So you understand these products, then I will tell the mechanism. So you are getting 2R, they will combine to form RR, that is alkane, then carbon dioxide is removed, and then this sodium combines with sodium OH minus to form sodium hydroxide, and what is left is hydrogen, that is removed as hydrogen gas. Now you take an example, CH3, in the place of R you have CH3, CH3COONA. So this is 2 molecules you take, and this is what we call it as sodium acetate on doing electrolysis with 2 molecules of water, that is the aqueous solution of sodium acetate you have to take. So when you do electrolysis, this CH3, they will combine to form CH3, single bond CH3. So because you have 2 molecules of CH3, so CH3, single bond CH3. This is what we call it as ethane. Then this carbon dioxide, they will be removed as carbon dioxide molecule, 2 molecules. Then this Na and OH, they will combine to form sodium hydroxide, 2 molecules of sodium hydroxide. And this hydrogen, they will combine to form hydrogen gas. So you are getting these products by doing electrolysis of the sodium salt of the acid, and this is what we call it as Gold's electrolytic method. So here we are getting an alkane, and in this alkane we are having 2 carbon atoms, but we are here you are using only 1 carbon atom. So when you use 1, that is an acid with 1 carbon, we are getting an alkane with 2 carbon. So if you are using 1, you are getting an alkane with 2 carbon. For example, you take methyl. If you use methyl, that is sodium acetate, then you are getting CH3, an alkane with 2 carbon. If you use C2H5, then you are getting C2H5, 4 carbon atoms, butane you are getting. So when you are using an acid with 1 carbon, you are getting an alkane with 2 carbons. That is, there is a double. When you are using an acid with 2 carbon, you are getting an alkane with 4 carbon. So you are getting an alkane with double the carbon atoms what we are using with acid. So the mechanism of Gold's electrolytic method. For that you take a beaker containing 2 electrodes connected to the positive negative terminal of the battery, and then you have a salt solution. Here aqueous sodium acetate is the salt solution that acts as an electrolyte, and here the CH3COO minus and then Na plus. You have an anion and cation. Now this one is anode and this is cathode. The anion will move towards anode. That means this CH3COO minus, which acts as an anion, will move towards anode. At anode, you have CH3COO minus, 2 molecules you have to take. Now this oxygen has 6 electrons. Since it is negatively charged, it has 1 odd electron. Now this bond has a pair of electron. This bond is nothing but a pair of electron. So this carbon will take this 1 electron and it is removed as carbon dioxide. So you are getting 2 molecules of carbon dioxide because we are using 2 acetate ion. So you are getting 2 molecules of carbon dioxide. Now you are left with CH3 with 1 electron. That is 2 molecules of CH3. Each one will have 1 electron, odd electron. That is what we call it as radicals. So you are getting 2 methyl radicals. So this is, we have methyl radicals. Then the negative charge you have, that is removed as 2 electrons. So you are getting 2 electrons. So here there is a loss of electrons taking place at anode. Now these 2 methyl radicals, they will share the electron with the odd electron they are formed. So they share that odd electron and you will be getting CH3 single bond CH3. So it is called as ethane. Since there is a loss of electron, so it is called as oxidation. At anode, oxidation takes place. Now we'll go to the cathode. So cation will move towards cathode. Here the cation is Na+. So at cathode we have Na+, 2 Na+ we have, and then water is there, and these 2 electrons, they will be accepted by here at cathode. So you will be getting, so these two water, you have H+ ion and OH- ion. This H+ ion will gain electron and it is removed as H2 gas. Then this OH, they will be formed as OH-. So you are getting 2 OH-. And this Na+ and this OH-, they will be formed as NaOH, sodium hydroxide. Since there is a gain of electron, here there is a gain of electron at cathode. So at cathode, reduction takes place. So at anode, oxidation, at cathode, reduction takes place. Now here we can say, at anode, there is a formation of ethane, CH3, and then carbon dioxide. So you are getting carbon dioxide and ethane. At cathode, we have hydrogen. Hydrogen is formed at cathode. Now in the solution, you have sodium hydroxide. So at anode, we are getting ethane and carbon dioxide. At cathode, hydrogen. In the solution, we have sodium hydroxide. So in this Golb's electrolytic method, we are getting alkane as the product. Alkane as the product. That is, here in this case, if you use sodium acetate, we are getting ethane as the product. And carbon dioxide is liberated at anode and hydrogen is liberated at cathode, and sodium hydroxide is formed in the solution. So this is the mechanism of Golb's electrolytic method. Next video we will do the remaining preparation. Thank you for watching.